Hey everyone, welcome back to the Deep Dive. We've been hearing from you about, well, honestly, some of the struggles you've been having, keeping those advanced AI workflows, well, flowing. And we hear, yeah, it's complex stuff. So today, we thought we'd jump right into LangGraph. It's just this pretty cool new toolkit that's part of that whole LangChain ecosystem. It seems like it's specifically designed to tackle these intricate challenges,
Yeah, absolutely. I mean, the goal today isn't just, to kind of skim the surface of what LangGraph is. I think we want to go deeper. We want to give everyone a real grasp of the why, the how, and the what, so to speak. What it is, why it matters, why it's different. And I think most importantly, how can this actually help? How does this change the way you're approaching these really sophisticated AI interactions that, honestly, I think a lot of people are finding pretty overwhelming right now. We want to make sure that when you walk away from this, you're thinking, okay, I get it. LangGraph can help me, kind of wrangle these systems a bit better, with more confidence and with less of a headache, frankly.
Yeah, exactly. And looking at the stuff you sent over, it seems like LangGraph is being presented as this way to get a handle on things, to see what's actually happening in these complex AI processes and to actually steer them, to coordinate them. And that seems really important when you're talking about building those, those big heavy-duty production level systems, especially when you have a bunch of AI agents all working together, All right, so let's get into this. What is it that LangGraph is trying to solve here when it comes to managing these crazy workflows?
Well, the research I've been doing, it points out that the way we're doing things now, the standard framework, it relies on these things called Directed Acyclic Graphs. DAGs, and they've served us well for sure, but they're kind of showing their age, especially when you start dealing with the way that modern LLMs are working. It's all about those back and forths, those dynamic interactions, the kind of stuff you're probably already working with. Think about it. Someone's chatting with a bot, they throw in some new info, and suddenly the bot has to go back to an earlier part of the conversation. Or maybe you've got a few AI agents and they're all trying to refine their work based on what everyone else is finding. DAGs, well, they're linear, they're one way. They don't really like going in circles.
So if I'm getting this right, it's those traditional DAGs are a one-way street, right? And LangGraph is built to handle more complex intersections, maybe even some roundabouts.
Yeah, that's a great way to put it. I like that, the roundabout, because that's what LangGraph is all about. It's saying, hey, we need to be able to go back to earlier steps if there's new info, to adapt on the fly. And it's not just about the structure. LangGraph is really big on this idea of strong state management. That means keeping tabs on all that data that's flying around the system. And then there's the adaptive execution part. Those are both key, really key for wrangling these super advanced AI systems. It's designed to deal with those limitations you were just talking about, the ones you get with those more straight line ways of doing things.
Okay, so this is where things get interesting, at least for me, because we're talking about, actually using this stuff. And I saw in the research that there were some pretty big updates, enhancements, they call them, that came out in 2025. What are the big ones, the ones that people who are dealing with this kind of complexity right now should really be paying attention to?
There are a few that really jumped out. First one, streaming support. Now, what this means is that the state of your AI workflow, it can be updated and communicated in real time. It's constantly evolving. And if you're building interactive systems, this is huge. It changes everything because now you can get that immediate feedback. Imagine you're making a really intricate diagnostic tool. With streaming, the person using it could actually see how the AI is thinking step by step, building that trust, that understanding, even before the final answer is ready.
Yeah, that makes a lot of sense. I could see how real-time updates would make things a lot smoother for the user, and to be super helpful to peek into the AI's brain as it works. What else is there?
All right, another big one, human-in-the-loop nodes. This is really important when you're talking about production-grade systems, the kind where you might need a human, a real person, to step in and make a judgment call at certain points, especially the critical decisions. LangGraph lets you build that right into your workflow. So your experts can check what the AI is doing, give their input, even redirect the whole thing if they need to. Think about something like a content creation pipeline. You could have the AI write the first draft, but then a human editor comes in, checks it over, and gives the final approval before it goes live. That mix of, automation and that human touch, It's really important for making sure things are high quality, especially in sensitive areas,
That makes sense, like to keep things reliable
Yeah.
and to make sure everyone's accountable, especially in those industries where there are a lot of regulations, right?
Exactly, exactly. And then there's the deep LangSmith integration. Now, if you're already using LangSmith, you know how powerful it is for like seeing what your LangChain applications are doing, debugging them. Well, LangGraph takes that and gives you these really advanced tools for visualizing, debugging, and tracing, but specifically for those more complex workflows, especially the ones with multiple agents. If you've ever spent like hours and hours trying to figure out why a system with multiple AIs is acting up, this kind of detailed insight is a lifesaver. You can actually see the whole conversation, the data being passed around step by step. It's amazing.
Oh yeah, I could totally see how that level of detail would be just so useful when you're trying to figure out where things went wrong.
It's a game changer for sure. And then we have persistence. This is all about being able to, save where you are in the workflow, like a bookmark, and then come back to it later. It's so valuable for those AI processes that take a long time or that use a lot of computing power. So if something happens, the system crashes, or you just need to pause it for whatever reason, you don't have to start from scratch. You can just like pick up right where you left off. It's all about making your deployments that much more robust.
Okay, yeah, those sound like really significant steps forward.
Yeah.
Especially when you think about all the complexities of managing multiple AI agents at the same time. Okay, so let's get back to basics for a second. What are like the core idea, the principles that LangGraph is built on? Like what's under the hood?
Okay, so there are three big ideas that LangGraph is all about. First one, graph structure. We talked about this a bit earlier, but the basic building block is the node. This can be an individual LLM agent, or it could be any other step in your workflow. It could be processing data, calling an API, anything really.
So it's like every single thing that happens in the AI workflow, it's a node on this graph, right?
Exactly. And these nodes, they're connected by these things called edges. Edges show how information and control flows through the whole workflow. But here's where things get really interesting. You have a thing called conditional routing. So you can set it up so that the path the workflow takes, it changes based on what happens at a particular node. You can also create loops so the workflow can go back to earlier nodes based on certain conditions. You can even have multiple paths that it can take depending on how things turn out. And that's where that whole adaptability thing we were talking about comes in. It makes your AI workflows super flexible, super responsive. Like no matter what the situation is, it can adapt.
I can see how that would be so powerful, to handle all these different scenarios. But it also sounds like it can get really complicated really fast. Like how do you even keep track of everything?
Well, that's exactly why LangGraph has built-in visualizations. You can use Mermaid or GraphViz, and they even give you a little bit of Python code in the docs. It shows you how to make like diagrams of your workflow. It's super helpful because you can like literally see the architecture, the logic of the whole thing at a glance. It just makes all those connections much, much easier to understand.
Yeah. Seeing things visually, I mean, that always makes it so much easier to understand what's going on compared to just staring at lines of code.
Right.
All right, so what's the next big pillar?
All right, number 2, state management. Okay, so because these workflows can have so many steps and loops and branches, you really have to keep track of the data as it moves around. Think of state like it's the memory of your AI workflow. It's all the messages, the decisions that have been made, any results that have been generated, all of that. And LangGraph uses this thing called Pydantic to make sure that the state is, well, valid. They actually have a Python example of a state class. It defines things like messages, which, that's like a list of all the things that have been said in the conversation. And then there's this thing called current step, which that just tell you where you are in the workflow. So all the data has to follow a specific structure, and that helps prevent errors, because if the data is messed up, it can really throw things off.
So it's like it has this really strict rule book about how data can be passed around, to make sure everything stays consistent.
Exactly. It's all about keeping things clean and consistent from start to finish. And state management in LangGraph, it's got 2 parts. It's real time, and it's persistent. We talked about the real-time part with the streaming updates, but the persistent part, that means you can save the state of the workflow at any point, and you can come back to it later. Like we said, it's super important with those long, complex processes where, things might get interrupted.
Got it. So it's like making sure your data is good and being able to like hit pause and then play again whenever you need to. Super important when you're dealing with real-world applications.
Yeah.
Okay, so what's the third one? What's the last big idea here?
All right, last but not least, coordination mechanisms. Now, this is all about how the different parts of your LangGraph workflow actually do their thing, how they talk to each other,
Right.
And LangGraph is super flexible here. It can handle, things happening one after the other sequentially, but it can also do things in parallel, where multiple agents or actions can be running at the same time. If you have tasks that can happen independently, doing them in parallel can really speed things up, It can make your whole workflow a lot more efficient.
Yeah, being able to run things side by side could definitely be a huge time saver. But what happens when, like, things go wrong? Because, let's be real, that happens.
That's where the error handling comes in. It's really robust. LangGraph can work with libraries like Tenacity, which what that means is you can set up these really smart retry strategies. So let's say a node has a problem. Maybe the network goes down for a second, or maybe an API has a limit on how many times you can call it. Well, the system can automatically try again. It can try a few times before it gives up. And we can't forget about the human in the loop stuff we talked about. That's part of the coordination too. Being able to step in manually. That's really important for like unexpected situations or for those judgment calls that really need a human brain. And lastly, for coordination, we have the advanced debugging stuff. Remember how we talked about the LangSmith integration? That gives you this super detailed trace of what happened. So you can go through the workflow, you can see the state at every point, and you can like pinpoint exactly where things went wrong. It's like having a detective for your AI.
Wow, so it's not just about telling the AI agents what to do, but it's about making sure they can do it reliably, and that you have the tools to understand what's happening and fix it when things inevitably break, right? Okay, so you talked about this big shift, going from those DAGs to these cyclical graphs. Can you break down why that architectural change is such a big deal? Like, why is it so important?
It's fundamental, really. It's like it opens up all these new possibilities. I mean, with cycles, your AI workflow, it's not stuck in that straight line anymore. You can do things like iterative reasoning. So the workflow can go back to earlier steps based on, stuff it learns later on. Imagine an AI trying to write a report, a really complex one. With a cyclical graph, it could write the first draft, then go back and do more research on a specific point, and then update the draft. It's like it's learning and refining its work as it goes.
So it's like the AI is, it's basically getting smarter. Like it can learn from its mistakes and get better over time.
Yeah, that's a great way to put it. It's almost like it's thinking, okay, I need more info on this. Let me go back and check. And then you have recursive processing. That's where the workflow can like correct itself. So the AI could analyze its own output, find mistakes, and then go back and fix them. This is hard to do with the DAG. Almost impossible, really. And then there's the adaptation part. The cycles and the conditional routing. It means the workflow can react to changes in real time. It's like it's always adjusting, always responding to new info. It's a much more, I guess you could say, dynamic and responsive approach.
It sounds like it makes the whole AI workflow a lot more, I don't know, intelligent,
Yeah.
adaptable, like it can think on its feet.
Mhm.
So you mentioned visualization earlier. Why is that like so important, especially when you're dealing with these more complicated workflows, the ones with all the cycles and stuff?
Because when you start moving beyond those simple, straightforward actions, things can get really messy really fast, especially when you have multiple AI agents interacting. Without visualization, it's like you're lost in a maze. You can't see where you are or where you need to go. Visualization gives you that map. It makes it so much easier to understand how things are connected, how they're working together, and if something goes wrong, you can use that map to like debug it. And as your workflow grows and changes, you can use that visualization to keep track of everything. It just brings a lot of clarity to a potentially very confusing situation.
So we have two kinds of visualization with LangGraph, right?
Right. We have the static visualization. Remember, we talked about using Mermaid or GraphViz to create those diagrams. They're really good for like documenting your workflow, giving you a high-level view of how things are set up. And then you have dynamic visualization, which that comes from the LangSmith integration. This one, it's like a live view of your workflow. You can see what's happening as it runs. You can see the state changing. You can follow the execution path. You can even spot errors as they happen. It's incredibly helpful for debugging and for making your workflows run better.
Seeing all that in action in real time, that sounds super powerful, especially when you have multiple AIs and you're trying to figure out what's going on. Okay, so can we look at some of the code examples that you shared just to like make sure we're all on the same page? Let's start with the basic workflow one, the Python one.
Sure. So this one, it's a really simple example. It's just two steps. It starts by defining this state class, which, it has a list of messages and a current step string. Then it defines two functions, collect info and process info. The first one, it just adds the text info collected to the messages list and sets the current step to process. And the second one, it adds info processed to the messages and sets the current step to end.
Okay, so it's just a very basic, do this, then do that kind of workflow.
Exactly. It's just to illustrate the concepts. Then the example shows how to use this thing called the state graph class to define the workflow. You add the collect info and the process info functions as nodes in the graph, and then you connect them with an edge. So the collect node goes to the process node. And then there's set entry point, which that tells the workflow where to start, and set finish point, which that tells it where to end. And then, of course, there's that visualized line that creates the diagram of the workflow.
All right, so that's like the bare bones of how to set up a LangGraph workflow, right?
Yeah, pretty much, just the foundation. Now let's look at the advanced multi-agent workflow example. This one, it shows some of the more, advanced stuff that you might use in a real system. So it starts with the state class, just like the other one. But notice that there's this decorator above the analyze security function. It says, at retry, stop after attempt. Remember how I talked about error handling? This is how you do it. So if that function has a problem, LangGraph will try it again up to 3 times. It's all about making the workflow more reliable.
So that's an example of, how you actually build that resilience into the system. Right.
Right. And then it defines this function called analyze performance, and it's asynchronous. That means it can run at the same time as other things. And that's really important when you have multiple agents that might take different amounts of time to finish. You don't want one slow agent to hold everything else up, So it defines these 2 nodes, security and performance, which those are the 2 analysis steps. And then it connects them with an edge. And then it shows how to, actually run this whole thing using Asyncio, which that's a library for asynchronous stuff in Python. And then it uses visualize again, but this time with GraphViz instead of Mermaid, just to show that you have options,
So we're seeing both, like the normal way of running functions and the asynchronous way, all within the same workflow. And we see how to build in that error handling, right?
That's really cool. Okay, so beyond these specific examples, what are some of the other things that make LangGraph a real option for using in production, when you're building real systems? The research highlights a few things that are really important for production deployments. We've talked about persistence, the ability to save your progress and come back later, really important for those long processes, And there's the human in the loop integration, which that's how you build in those manual checkpoints, those points where a human needs to come in and make a decision. Super important for quality control and for compliance and for all those edge cases that you can't always predict. And then you have the streaming capabilities, those stream and a stream methods. Those are essential for chatbots, anything that needs to be really interactive and responsive. And finally, there are these things called pre-built graphs. Those are templates for common tasks. If you're building a chatbot, there's already a pre-built graph for that. So you can really speed up your development. You don't have to start from scratch every time.
Okay, it sounds like, LangGraph has all the pieces you need to build, a really robust AI application, one that can actually handle, real world scenarios. So for someone who's listening to this and they're intrigued, they're thinking, maybe I should check this out. What's the first thing they should do?
Well, first things first, they got to install it. They need the libraries. And the docs have the exact command. It's pip install LangGraph developer.0.11 LangChain core 0.1.0. So they just run that in their Python environment, and they're good to go. They've got the core LangGraph library and all the stuff it needs to work.
Awesome. Easy peasy. So let's wrap this up. Big picture. What are the main advantages of using LangGraph? What are the key takeaways here?
Well, it addresses those challenges we were talking about at the beginning,
Right.
First, state integrity. It does a much better job of managing the state, making sure the data is good, thanks to Pydantic. Second, dynamic workflows. It can handle those cycles, those loops, that back and forth that's so important with modern LLMs. It's not stuck in that linear way of thinking anymore. Third, enhanced debugging. The LangSmith integration, it gives you those really powerful tools for understanding what's happening, for finding and fixing problems. And lastly, robust execution. It can handle errors, it can retry things automatically, and it gives you options for, bringing a human in if you need to. So it's all about building more stable, more reliable AI systems.
So to put it all together, it sounds like LangGraph is giving us a new way to build these complicated AI workflows. It's more flexible, more resilient, and more transparent than the old way of doing things. And it's especially good for those workflows that have, multiple AI agents that are like talking to each other and working together, because it embraces the power of cycles, and it really understands how important it is to manage the state correctly.
Yeah, that's it. It's a big step forward. We're building more dynamic, more adaptable, and honestly more manageable AI systems.
This has been a really, really insightful look at LangGraph. It sounds like a really powerful tool, and it's come along at just the